Welcome to the frontend no limits. First example is the React component. Here we have a small app that can show offline banner when there is no connection. It looks like this in the browser. When the user is offline, then they see the banner. After the connection gets recovered, the banner gets hidden. As we can see, it violates the single responsibility principle because it holds the state, manages subscriptions to the connectivity change, and has implementation details of the layout. In other words, it's really responsible for several stuff, that's why it has more than one reason to change. But clearly, it should be responsible for only one thing: gather all the system components together and delegate implementation details to the underlying system parts. We can adhere to the principle by employing decomposition. This means we need to move out all these implementation details into separate functions and components. After that, our code will become more modular, and since that change for different reasons and at different pace will be separated. Let's move on to the good example and see all this in action. As we can see, now the app component is only gathering all components together and nothing more. It's very small and maintainable. Changes into one application part won't have a chance to affect the code of the other parts. So the logic responsible for connectivity stuff was moved into a dedicated custom hook. We have a separate OfflineBanner component that utilizes this hook. Moreover, now this hook is a completely reusable unit that can be consumed by any application part. Finally, the main and aside contents were moved into dedicated components as well. In the Typescript example, we have a function for loading images from the API. This function is quite big because it does lots of stuff. I intentionally took more production-like example in order to show the code from different angles. It violates the single responsibility principle because it has several reasons to change. For example, by the name we can think that its responsibility is to load images, or I would say to orchestrate the loading process. So if the validation rules gets changed, then this function needs to be modified. But implementation details of validation are not the responsibility of the load images. We can improve this function by decomposing all these implementation details into separate functions. Let's move on to the good example. Firstly, we encapsulated details for fetching and logging into dedicated factory functions. Our API call became very concise and readable. loadImages is a consumer, and as a consumer we don't care how exactly requests are implemented. Sending logs doesn't look significantly different. However, there are other advantages, like the unified interface for the whole app, and if we need to change a logger to another solution, we will need to do a change only in one place instead of two as it was in the bad example. Validation logic is now also encapsulated. The same goes for creation of client images. One might say, hey, it's still a big function. Yes, right, but here I'd like to point out one very important thing. Following the principles should not bring harm, only the good. In other words, we can decompose more and more, but let's stop for a moment. Ask yourself, does this piece of code look readable enough? Will it be difficult to do changes? If both answers are no, then leave it, don't overcomplicate. That's it for now. Thank you for watching and see you in the next videos.